Hello guys, so in this video I'll be working on some fractions for this should be like grade 4 stuff, or it is grade 4, and it deals with fractions. Now I've seen questions being given like this. For example, let's see, 9 upon 27 is the same as 1 upon, and you have like 1 upon what? A box here. Now to work a question like this, you don't know what should be here, but you can say let it be x. So you put an x here because you want to know what is x. Now this here can be simplified like this. You cross multiply 9 by x, and then you multiply 27 by 1. Right? So you'll have 9x is equals to 27. Now you want to know what is x, so x has to come here. So this here is really 9 multiplied by x, right? Is equals to 27. Now you want x, so you need to divide by 9 because you want to get rid of the 9. So you divide both sides by 9. So this and this cancels, so 1, 1. So you have x is equals to 27 divided by 9, which is pretty much 1939. So in this question, 9 upon 27 is the same as 1 upon 3 because x here would be 3. Now, you might ask, so why am I cross multiplying? Why did I multiply the diagonals here? Right? So, the general rule is this. If you have A upon B is equals to C upon D, this is equivalent to AD, right? AD is equals to BC. Now we'll try to prove this. All right? So let's do that now. Get rid of that. So I'm saying that this here, right? We want to prove this. How I came up with this. Now think of this. A upon B is equal to C upon D. If I multiply both sides by B, what will I have? So I'm going to get A upon B times B is equals to C upon D times B. So what will happen? The B and the B goes out. So you have now A is equals to CB upon D. Now if I multiply both sides of this here by D, because I don't want a D, I'm trying to linearize this expression here now, or this equation. So what will I have? The next step, this will give us A multiplied by D is equal to CB upon D multiplied by D. This D and this D cancels out. So you have AD is equals to CB which is the same as saying AD is equals to BC, right? Because it doesn't matter if you're multiplying the order here. What I'm saying is that C multiplied by A is equals to C times B is the same as B times C. So I'm just writing it in a format here. So you can relate this here now to what? Yeah, you can relate this to this. How we end up with this here. All right. Now let's try some other questions here. How much I can. Okay. So let's take a question here. Supposing you have 4 upon 20 is equals to 1 divided by a box. What you need to fill in this box here. Now, if you don't see the relationship, 4 upon 20 is the same as 1 4 5 4. So this is going to be 5. So what am I saying is that 4 upon 20 is equivalent to 1 upon 5, right? Now, that's one way. If you try this way now, if you didn't get it, if you didn't understand it that way, 4 upon 20 is equals to 1 upon x. This means that 4x is equals to 20. So 4x divided by 4 is equals to 20 divided by 4. So this is going to cancel. So x is equals to 20 upon 4, which gives you 1 and 5, mean x is equals to 5. So that is how I got this 5 here. All right? So if you see something like this, they're pretty much the same. Now, 1 upon 5 or anything, let's say 1 upon 5. If I multiply the top by 4 and the bottom by 4, I'm going to get what? Multiply by 4, multiply by 4. It's the same as 4 upon 20. All right, so let's try some more. Supposing I have A upon B. Now, and I multiply the top by 5, and I multiply the bottom here by 5. I'm going to get 5A upon 5B. This is the same as A upon B because this and this can cancel. So, 2 upon 7 is the same as, let's say I multiply the top by 2 and the bottom by 2. I'm not changing anything. So it's going to be 4 upon 14. This and this is the same. Now, in the questions you had like 4 upon 14 is the same as, let's say they give you 2 upon something here. So in that case, you are dividing here. How from 4 to 2, what you did, you divide by 2. It means 14 must be divided by 2 and you get 7. Right? So this is how you should attack questions with respect to, simple fractions. I don't know what you want to say, but these are maybe for a grade 4 student, this is rough, but we'll stop here for now. So until the next video. Okay, guys?